Hello guys, in this video I'm sharing with you 5 different questions with complete solutions related to hyperbolas. We will find the equation of the hyperbola, the foci, vertices, eccentricity, the area of central box, the equation of asymptotes and other stuff. At the end of the video, you can find 3 practice questions for you to do it yourself. The answers only are provided at the end. Let me just take a few seconds to highlight some basic background about hyperbolas. There are 3 slides here. The first one, shifted hyperbolas. Shifted means the center is not 0, 0. H and K, this is the center. So this is the center here, H and K. It can be 0, 0 at the origin. It can be any other place. So we can shift the graph to the right, to the left, up and down. So that's is the meaning of shifted hyperbolas. There are transverse axes for each hyperbola. If this one is horizontal like this, see between the vertices, then the equation becomes x minus h squared over a squared minus y minus k squared over b squared equals 1. That is in standard form. So I put all the formulas that you might need here, arranged in a nice way, easy to understand. Center is hk, the vertices, see this is the vertices plus or minus a plus h, this is shifted, 0 plus k. Now, let me just mention, if the center is 0, 0, just replace everything on this slide. H is 0, k is 0. Foci plus or minus c plus h, 0 plus k. Foci are here inside. Foci are inside the hyperbola. And each hyperbola has 2 straight lines. We call them asymptotes. Asymptotes, I will give you one slide how to find them. Now in this case, it's y equals plus or minus b over a x minus h in the bracket plus k. As I mentioned, if the center is 0, 0, replace h is equal to 0, k is equal to 0. Now in hyperbolas, always there is a nice formula that relates a, b, and c. So c squared is equal a squared plus b squared. This is where the transverse axis is horizontal. Now look at the second one here. This is the second slide. Shifted parabolas, the transverse axis is vertical. Vertical means we start with the y. So the general equation in standard form, y minus k squared over a squared minus x minus h squared over b squared. So if the number here, the positive under the y, it's vertical. If the positive number under the x, it's horizontal. Same thing here, the vertices now becomes 0 plus h. See, these are the vertices, 0 plus h, and then plus or minus a plus k, because there are 2 vertices, 2 foci, 0 plus h, plus or minus c plus k. Now this formula does not change. For all hyperbolas, we have c squared is equal to a squared plus b squared. Look at this, the last slide before we start the examples. Quick way, very quick way actually, for finding asymptotes of the hyperbola. 2 steps in all hyperbolas, you can replace 1 by 0 because you have 1 here in the standard form. Suppose this is given hyperbola, any hyperbola. Replace 1 by 0 and then solve for y. So I did it here in general. Put 1 here, 0, replace it. This is step 1. Step 2, solve for y. So I leave this y on one side, take this on the other side, take the square root of both sides. You get 2 lines here. The slope will be plus or minus a b over a. All right, let's see, question number 1. Sorry guys, question number 1, I said not easy. It is easy, but not easy. I will tell you why it's easy. It's easy because the center here is 0, 0. So h, there's no shifting. It is not easy because we have some ugly numbers here. square root of 18 in the question. So it is both ways. Let's see, find the equation of the hyperbola foci, square root of 10, 0 minus square root of 10, 0, passing through the point 4 square root of 18. You can pause a little, please, and check what can you do here. Which equation you have to decide. There is one video about ellipses. If you did not see it, you can see it. Same starting point. You have to decide, is this vertical or horizontal? So I advise you in all these questions, ellipses, hyperbolas, parabolas, conic sections, make a little sketch. If you have the foci, if you have the vertices, whatever in the given, try to sketch it. So in the next slide, I will sketch the question here for you. You see, this is the sketch. So the foci is square root of 10, 0, so it will be here somewhere, 3 point something, minus square root of 10, 0, it will be here on the x-axis. So you can imagine that hyperbola here, see on the graph, you can imagine it. So the foci are there passing through the point 4, 1. So the hyperbola will be this way, this way. Now we can write the equation. See, here is the equation. X minus h squared over a squared, y minus k squared over b squared equals 1. So the aim, the idea behind sketching is to know which type of the hyperbola. Is this slide number 1 or slide number 2? Now, let's plug in the numbers here. H and K here. Y, H and K. This is the center. It's 0, 0. See? Because the foci, they lie on the x-axis. So I put H, 0, K, 0. Now, X and Y, from the given point, just I put 4 for the X, square root of 18 for the Y. Now listen here. A squared, B squared. I don't know A squared, I don't know B squared. But I know a relation between A squared and B squared. C squared I will find the distance between the foci to C. So C will be plus or minus square root of 10. It's so simple. Square it, you get both sides. C squared is equal to 10. So I put here 10. See, in the C squared, I put 10. So B squared will be A squared minus 10. Replace it here. I know this is not easy equation. See this one here? That's the difficult part. The easy part, H and K is 0, 0, no shifting. Difficult part, maybe difficult. This is the equation where you have to find A squared. Big story here. I will take this equation on the next slide and do it. You can pause a little if you like and try it yourself. Try to find A squared. Okay. Now, this is the equation we get from previous slide. You can remember the equation. 16 over A squared minus 18 over 10 minus A squared is equal to 1. Any equation I mentioned maybe before, any equation that has fraction, find the LCD. The LCD means the least common denominator. So it's A squared times 10 minus A squared. Multiply on both sides. You see here on both sides. So if you multiply this LCD on both sides, each term, we have term, 3 terms. So it becomes 16 times 10 minus A squared minus 18 A squared is equal to A squared times 10 minus A squared. Now you have to rearrange this equation. You have to expand it, distribute the 16, distribute the A squared, you will get this one here. You see this nice equation? No, it's not nice. A to the power 4 minus 44A squared plus 160. We need to factor it. That's power 4. If I factor it, well, the product will be 160 and the sum will be minus 44. So I can think of the numbers minus 4 minus 40. See, now I get this one here. Sorry for these numbers, guys. a squared minus 4a squared minus 40. Now, if I take each factor, so a squared is equal to 4 or a squared is equal to 40. Let's see. If a squared is equal to 4, remember the equation from previous slide, b squared 10 minus a squared. Put 4 there, so b squared will be 6. If you try the second one, a squared is 40, so b squared will be 10 minus 40, which is minus 30. Cannot be negative, b squared, so that's rejected. So now we take x squared over 4 minus y squared over 6. You see this simple, easy equation? That's the answer. Simple, easy equation. X squared over 4 minus y squared over 6 is equal to 1. Let's move to question number 2, please. Question number 2, given the equation of the hyperbola in expansion form, and we need to find 3 things: eccentricity, the area of central box, which we call it sometimes fundamental rectangle, and the equations of asymptotes. Before we do all this, we have to do something important we mentioned many times in other videos, especially about ellipses. Can you know the idea here? What is the main idea by looking at the question? I think you know that. It will be completing the square. So I take the equation. It's not easy equation actually. So this is the equation. Rearrange it. Rearrange it, I mean by rearranging, take the x's together, 25x squared plus 100x, just put it aside, and take the y's together, minus 9y squared minus 54y plus 10 is equal to 0. Now we need to complete this square on the x and on the y. On the x, I take common factor. Why I take common factor? Because if you remember, completing the square, the first condition we should have, the coefficient here of x squared should be 1. So if I take 25 common factor from the terms that have x's, so it will be x squared plus 4x. Same thing for the y. I take minus 9 out, so it will be y squared plus 6y. 6 times 9 is 54, plus 10. Now inside the bracket, see, this is the completing the square. We complete the square. It is not complete, we completed it. We take the coefficient of x here, 4. Divide by 2, 2. Square it, we add 4, subtract 4. Now in the y, we do the same thing here, 6y. The coefficient of the y is 6. Divide by 2, 3. Square it. So I add 9, subtract 9. Simplify now the equation. This is x plus 2 squared. Multiply, you need 25 outside times the minus 4. See, only 25 will multiply with the minus. And this is perfect squared. So that's minus 100. Now inside here we have y plus 3 squared. Multiply by 9. Minus 9 plus 81 plus 10. Now we need to simplify more and more. So it says here, simplify the equation and see the continuation on the next slide. So from previous slide, I simplified the equation. I think you did the same. 25x plus 2 squared minus 9y plus 3 squared is equal to 9. So we have to divide by this 9. Why? Because we need 1 on the other side. This is what we call standard. So divide by 9 is 1. Divide by 9, there is nothing here. Divide by 9. See? Now, you can leave it like this. This is correct equation here. This is the hyperbola here. Or you can rewrite it. See, this is the way we write in the book. This is the standard, general standard. X plus 2 squared, 9 divided by 25. This is the number here, a squared. y plus 3 squared. If there is nothing there, just put 1 over 1 is equal to 1. Now this is a hyperbola. The center is -2, -3, HUK, remember that. The transverse axis is horizontal. So a squared is now 9 over 25. So a plus or minus 3 over 5. B squared is 1. So b plus or minus 1. Okay, now we start answering the question. We start now, after completing the square, we start answering the question. So a squared is 9 over 25. B squared is 1. In hyperbola, we have the formula c squared is equal a squared plus b squared. Put c squared, we have to find it, 9 over 25 plus 1, which is b squared. Make the LCD here. So c squared will be 34 over 25. Take the square root, plus or minus square root of 34. We cannot simplify it, over 5. Now we come to the formulas. Part A, eccentricity, c over a. Just put the numbers. The area of the central box for AB. So it's 4 times 3 over 5 times 1, 12 over 5. Now one slide for finding the asymptotes. I think I mentioned before, slide number 3, if you remember, there is a quick way to find the equation of asymptotes for any hyperbolas, only for hyperbolas. The steps are 2 steps. Remember that. Replace 1 by 0, solve for y. Replace 1 by 0, solve for y. So we take the equation, the standard form. See, this is the equation here. I take the same equation here, equals 0. I change the form here, so I put the 25 because it makes it easy. Replace 1 by 0 and then solve for y. So I take this part, y plus 3 squared on the other side equals 25, x plus 2 squared over 9. Take the square root of both sides. So you get y plus 3 plus or minus 5x plus 2 over 3. Now what are these? These are the 2 lines, the asymptotes. These are the limits where we graph the hyperbolas. Now these are lines because see the power on the x is 1, the power on the y is 1. So if you take the plus 5 times this, it will be positive slope. And then I left this as little homework for you. Add and subtract here, simplify the equation, you will get this one. Check it yourself. Y equals 5 over 3, x plus 1 over 3. So this is the slope here of the line, positive slope, 5 over 3. The slope of the line, the asymptote. If you take the negative side, minus 5, you simplify the equation, you get minus 5 over 3, x minus 19 over 3. Please check these as little homework. Now, question number 3 is a little fast. What does the following equation represent? What do you think we can do here? I think you know the story now. If you have equation in this, we call this general form or expansion form. So the equation is expanded. We need to make it standard. Then we can decide what type. Sometimes when we complete the square, you can find an ellipse, you can find a hyperbola, vertical, horizontal, you can find other stuff. So let's rearrange the equation first, then complete the square on the x and on y. So I take the x's together, as I did before, the y's together, 16 here. Take 16 common factor from the x. You can go slowly here. You can do it on the paper. It's better, you understand better. Take in a minus 9 common factor. So y squared will be minus 8. 9 times 8 is 72. 16. Now we go inside the bracket. X squared plus 2x. Divide this 2x by 2. Squared, you get 1 and minus 1. 8 divided by 2, you get minus 4. Add 16 minus 16. We did this before many times, completing the square. So when you complete the square here, you have to be careful, please. Please, please, please. Be careful and do it at least 2 times because we have many signs here, negative and positives. Listen, 16, inside the bracket we have x plus 1 squared minus 1. Okay, now clear. Minus 9 we have, minus 9 there, y minus 4 squared minus 16. We have the plus 16 outside the question. Now, 16 times this will be 16, x plus 1. This is where we have to be careful. 16 times, this 16 times minus 1, remember, minus 16. Keep it. Minus 9 times y minus 4 all squared. Minus 9 times minus 16. See, minus 9 times minus 16 plus 144. And we have, in the question here, we have 16. Remember the minus 16 at the beginning cancels out with this 16. And plus 144, take it on the other side. Little tricky here. So it becomes minus 144. Now we divide by minus 144. Each term, look at the equation now. See, when you divide this one on the right side, you have 1. This one in the middle, minus 9 over minus 144 becomes plus. So I put it at the beginning, y minus 4 squared over 16. And the first one here, the x plus 1 squared becomes minus x plus 1 squared over 9. So the center here, always h with the x, k with the y. So the center will be here minus 1, 4. So this equation represents a hyperbola. Transverse axis vertical, because they have the positive here under the y. These are the vertices if you want to find them. And this is the foci. You can check the formulas in the first slides. Question number 4. Given the equation of hyperbola, this is not difficult, maybe. We need to find 2 things here, the vertices and the eccentricity. See this one, it is half arranged. You see, sometimes the equation is ready in standard form. Sometimes you have to complete the square. It takes time. This one is 50-50. So I give you 20x squared minus 4 in the bracket. Y minus 3 squared is equal 84 minus x squared. So you can continue to rearrange it. So this is like 50% arranged. You can pause here and try it to find the equation in standard form. The first thing you have to do in any question, in ellipses, hyperbolas, parabolas, any conic sections, you have to write the equation in standard form. Okay, what we'll do, I will take the x squared from the right side here, take it on the left side. You see this x squared? So it becomes 21x squared. Minus 4, y minus 3 squared is equal 84. Now let's divide by 84, divide by 84, divide by 84. Because we have to make this number 1. So y minus 3 squared over 21. And here we have x squared over 4. That's the equation. This is the standard. You see, the 4 is under the x squared. That's the positive a squared. 21 under the negative. So we can continue in the next slide. So look at the center here. Center x minus 0 squared. So center will be 0, 3. We can have h and k both zeros. We can have h and k sometimes h 0, sometimes k 0, sometimes both are not zeros. Now from slide number 1, vertices, remember these are the formulas. With shifting a plus h 0 plus k minus a plus h 0 plus k, just plug the numbers in. So a squared is 4 here. So a will be 2 minus 2. Minus a here, put minus 2. H is 0. K is 3. So these are the vertices. 2, 3, minus 2, 3. You can sketch it if you like. Remember here, a squared is 4, b squared 21, c squared. What is c squared? You can figure it out so easily. C squared is 25. So C will be plus or minus 5. If we need eccentricity, E equals C over A. C is the 5 here, or A is equal to 2. 5 over 2, 2.5. The last question, really nice. Similar to question number 1, but there are differences. Similar to question number 1. I gave you the foci here, and I gave you the foci in question number 1. I give you 1 point on the graph. Remember the foci in question number 1, they lie on the x-axis. Here we have shifting. See, h and k are not zeros. That's the difference. And also, the point here is more difficult point. Minus 3, this is the x value. 1 plus square root of 35, this is the y value. So what do you think the advice here, the big advice for question number 5? The big advice, you have to decide which type of hyperbola is this one. So sketch it. I will show you how to do it. Sketch it. Take the foci, just simple numbers. Minus 3, 7, put it on the graph here. See, minus 3, 7, this is F1. Minus 3, minus 5, this is F2. Now you can imagine this one, the hyperbola will be like this. See, they lie up vertical. So this is the hyperbola we have to find. Passing through the point minus 3, 1 plus square root of 35. So this is the point here. This is x and y. Transverse axis is vertical. Foci lie on transverse axis. The distance between F1 and F2 is 2c. So absolute value of A minus B. 2c, c will be 6. C squared will be 36. Leave it now. Now the center is the midpoint. See here back, I'll show you back here. The center here is the midpoint in the middle between F1 and F2. So I just put the formula from algebra. The center is the midpoint x1 plus x2 over 2, y1 plus y2 over 2. Put the numbers, you get minus 3 and 1. So this is h and k. Now, hyperbola equation. Now here the story comes, please. Be careful. From the second slide, this is a vertical transverse axis. Y minus k squared over a squared minus x minus h squared over b squared. So I have to put the numbers. Now be careful, what are the numbers? Y here, you see y is this. This is the y here, minus k. This is k here, 1. So the y minus the k. X is minus 3, minus h. H is minus 3, so it becomes plus 3 here. Be careful. So minus 3 plus 3 is 0. So all this term will disappear. That's why we can find a squared. Again and again, only this part we have to be careful. X minus h. X is the point given, it's minus 3. Minus, in the formula, h. H is minus 3. So minus 3 plus 3. This will disappear. Now, so this part here, this term will disappear, as I said. Plus 1 minus 1 inside the bracket will be 0. So we are left only with the square root of 35. When you square it, you get 35. 35 over a squared equals 1. You see that? Directly you say a squared is equal to 35. Cross multiply. We found already c squared, 36. Now we need b. In hyperbolas, always, C squared is equal A squared plus B squared. So B squared will be, take A squared on the other side, 36 minus 35, 1. So now that's the equation. Look at the nice equation here. Y minus 1 squared over 35 minus x plus 3 squared over 1 is equal to 1. Or you can write it this way. It's up to you. This is better here to make sure this is b squared 1, a squared 35. Okay. Now practice number 1, read it, please, and try it. Practice number 2, as usual. Practice number 3. And then the answers are there. Practice 1, the answers. Practice 2, the answers. Practice 3, the answers. And thank you very much for watching. I hope I can see you in another video with another topic. Thank you very much.